Hello my friends, welcome back to my channel. This is Walter here, taking you through A-level pure mathematics papers. So right now, we're going to be doing the May June 2020 paper. That's paper 12. So let's get started. Let's start with number 1. Find the coefficient of x squared in the expansion of x minus 2 over x all to the power of 6. Now for this one, we can start with the general expression for the binomial expansion of a plus b to the power of n. That's ur plus 1 is equal to n choose r, a to the n minus r, b to the r. Which means for this binomial, a is x and b is minus 2 over x, and n is the power 6 here. So we are saying the general expression will be ur plus 1 is equal to 6 choose r and x to the power of 6 minus r and b, which is minus 2 over x to the power of r. Now I can split this into constants as well as x terms. So for the constants or the coefficients, we will be having 6 choose r, and we also have minus 2 here to the power of r. So these are the constants or the coefficients. And then we also have the x terms. And for the x terms or the terms in x, in this expression, we have x to the power of 6 minus r. And we also have from here, that's 1 over x, which is x power minus 1. So times r, that's x to the power of minus r. And this can be simplified to x to the power of 6 minus 2r if we add the powers right here. So we now have the general forms for all the coefficients in the binomial expansion and all the x terms in the binomial expansion of this. Now, if we are going to get a coefficient of x squared, it means the x term, which is x to the power of 6 minus 2r, is x squared, which therefore means that equating the powers, 6 minus 2r should be equal to 2. That's minus 2r is equal to minus 4. So we can solve for r coming out as 2. So we now know that for the term in x squared, r is equal to 2. So therefore, the coefficient of x squared should come out as, using this expression, that would be 6 choose 2 and minus 2 to the power of r, which is 2. Now we know that 6 choose 2 is 15 and minus 2 to the power of 2, that's 4. So we get the answer coming out as 60. So that's what we get there for the coefficient of x squared. Let's scroll down to part B. Find the coefficient of x squared in the expansion of 2 plus 3x squared bracket x minus 2 over x to the power of 6. Now, we are multiplying two brackets here, and we know that in our process of multiplying, 2 is going to multiply the second bracket, and from there, we should get a term in x squared. So what kind of term should 2 multiply in the second bracket to give us a term in x squared? So we know that it should be a term in x squared. So it's 2 times a term in x squared. And we also know that 3x squared is going to multiply the second bracket, and that's plus 3x squared. And what should 3x squared multiply in the second bracket to get a term in x squared? Since x squared is already here, it means there has to be a constant term that we should multiply 3x squared with to get a term in x squared. So it's a constant or a term that is independent of x. So we already have a term in x squared in the binomial expansion of x minus 2 over x to the power of 6, and we obtained it already as 60. So we've got 60x squared as the term in x squared. So this part we already have. So what we now need to find is a constant or the term independent of x in the binomial expansion of x minus 2 over x to the power 6. So we're saying for the term independent of x, we know that the x term, since it's a term independent of x, it should be x to the power of 0. Because x to the power of 0 is 1, and that's a constant. That's a unit constant. So the general expression for the x terms, we got it to be x to the 6 minus 2r. So x to the power of 6 minus 2r should be equal to x to the power of 0, which means 6 minus 2r is equal to 0 by equating the powers. And if we are going to solve for r from this little equation, we get r coming out as 3. So we now have r equal to 3, which therefore means the term independent of x is going to be, using the formula for the coefficients, that's 6 choose r and minus 2 to the power of r. So it's 6 choose 3 and minus 2 to the power of 3. That's the coefficient. And that's the term independent of x. This gives us 6 choose 3 is 20, and it's times minus 2 to the power of 3, that's minus 8, and this gives us minus 160. So we now know the term independent of x here to be minus 160. So it therefore means that the term in x squared should come out as 2 of a term in x squared, which we said we got as 60 here. So that's 60x squared. And then that's plus 3x squared times the constant, the term independent of x, that's minus 160. So this gives us 2 times 60, that's 120x squared, and 3x squared times minus 160, that's minus 480x squared, and this gives us 120x squared minus 480x squared is minus 360x squared, and therefore our answer is minus 360. That's the coefficient of the term in x squared. So we can now scroll down to the next question. That's question number 2. Part A. Express the equation 3 cos theta is equal to 8 tan theta as a quadratic equation in sin theta. So here we've got 3 cos theta is equal to 8 tan theta, of which we know that tan theta is sin theta over cos theta. So we can actually multiply both sides by cos theta and this side by cos theta, and this is going to give us 3 cos squared theta is equal to, cancelling these ones out, we get 8 sin theta. And from here I'm going to use the identity and say cos squared theta can be expressed as 1 minus sin squared theta. So that's equal to 8 sin theta. Simplifying the brackets, we'll be having 3 times 1, that's 3, minus 3 times minus sin squared theta, that's minus 3 sin squared theta, and that's equal to 8 sin theta. And if I take everything to the right side, that means that I'll be having positive 3 sin squared theta plus 8 sin theta minus 3 and that's equal to 0. So this is the quadratic equation in sine theta. So that's it for part A. Let's go to part B. On part B, it says, hence find the acute angle in degrees for which 3 cos theta is equal to 8 tan theta. So we now want to solve this equation here. Now, we had expressed this equation as a quadratic, so we have it like this. So this is what we're going to use. So I'll place it here. So from here, I'm going to say let y is equal to sine theta, which means 3y squared plus 8y minus 3 is equal to 0. So I can factorize this, and factorizing this we get 3y minus 1 bracket y plus 3, which therefore means that either 3y minus 1 is equal to 0 or y plus 3 is equal to 0. And here y is equal to a third, and here y is equal to minus 3. So therefore, we are saying that sine theta is equal to a third, or here sine theta will be equal to minus 3. So we know from the quadrants that sine theta can have an acute angle value only in the first quadrant, and that's when sine theta is positive. So this here will not give us an acute angle. So we know that theta is equal to arcsine of a third, and we can type that in. And we get the answer as 19.5 degrees. So therefore, theta is equal to 19.5 degrees. And that's the acute angle here giving us the answer. And that's it for part B. Let's scroll down to the next question. That's question number 3. Question number 3. A weather balloon in the shape of a sphere is being inflated by a pump. The volume of the balloon is increasing at a rate of 600 cubic centimeters per second. The balloon was empty at the start of pumping. So on A, find the radius of the balloon after 30 seconds. So here we're saying, from the information given, the volume of the balloon is increasing at a constant rate of 600 cubic centimeters per second. So we're saying since the volume is increasing at 600 cubic centimeters per second, we can therefore say the volume after 30 seconds should be equal to 600 times the number of seconds, that's 30. So we get 18,000 here. So that's 18,000 cubic centimeters. Now we know that the volume of a sphere is calculated 4/3 pi r cubed. And we can make r cubed the subject, and we know that that will be r cubed is equal to 3v over 4 pi. So this therefore means that r cubed is equal to 3 times v, which is 18,000, all divided by 4 pi. So I'll type this in. So that's 3 times 18,000 divided by 4 pi, and this gives me 4297. So r cubed is equal to 4297. So for r, we'll do the cube root of that. So that's cube root of 4297. So with my calculator, I'll just go shift, then cube root, then ans equals, so I get 16.3 to 3SF. So R is equal to 16.3, and that's in centimeters, and that's the answer required by this question here. Let's move on to part B. Find the rate of increase of the radius after 30 seconds. So here we're going to use the chain rule. So that's dr by dt, that's the rate of increase of the radius, and it's equal to dr by dv times dv by dt. So here the dv's seem to cancel, so we still maintain the dr by dt. So do we have dr by dv? Now I would want you to remember that we said the volume of a sphere is 4 over 3 pi r cubed. So if we find dv by dr differentiating, we will get 4 over 3 pi times 3 r to the power of 3 minus 1, that's 2. Okay, and the 3's here will cancel, so we just left with dv by dr coming out as 4 pi r squared. So this is dv by dr, which means dr by dv will simply be 1 over 4 pi r squared. And this should be multiplied by dv by dt. Now we already have dv by dt given here, where the question was saying the volume of the balloon is increasing at a constant rate of 600 cubic centimeters per second. So that's dv by dt. So if I come here for dv by dt, I will put the 600 here. So therefore we're saying dr by dt is equal to 600 all divided by 4 pi r squared. But you see, after 30 seconds, we had obtained in part A that r will be 16.3 centimeters. So I'll substitute 16.3 centimeters for r. So we'll be saying, since r is 16.3, dr by dt is going to be 600 all divided by 4 pi times r squared, which is 16.3 squared. So let's type that in. So we'll be having here 600 at the top, then 4 pi times 16.3 squared. And this gives us 0.180 to 3SF. So that's 0.180, and that's in centimeters per second. Question number 4. The nth term of an arithmetic progression is half of 3n minus 15. Find the value of n for which the sum of the first n terms is 84. So what we've been given here is an expression for the nth term. So that's un is equal to half of 3n minus 15. So this means that I'm able to find the value of the first term and also of the common difference. The first term is u1, and that will be half of 3 times 1 minus 15, which is half of 3 minus 15, and that's minus 12. And this gives us minus 6. So since we have u1, I'm going to also find the second term, u2. That's half of 3 of 2 minus 15, which is half of 3 times 2, that's 6, and 6 minus 15 is minus 9, and half of minus 9 is minus 4.5. Therefore, I can find the common difference d by saying u2 minus u1. Second term, u2 is minus 4.5, and minus u1, which is a, the first term, that's minus 6. This gives us minus 4.5 plus 6, so that's 1.5. So we have here the first term is minus 6, that's a, and the common difference d has 1.5. So now that we have these two, the question says, find the value of n for which the sum of the first n terms is 84. So we know the formula for the sum of the first n terms of an AP. That sum to n is n over 2, 2a plus n minus 1d. So this is the formula for the sum of terms of an AP. So we'll now say that's n over 2 of 2a, that's minus 6 for a, plus n minus 1d. d is 1.5, so times n minus 1. And this should give us 84 here. I usually prefer to start by even multiplying both sides by 2, so that we do away with the fraction here. So we now have n left, and here 2 times minus 6 is minus 12, plus 1.5 times n, that's 1.5n, and 1.5 times minus 1, that's minus 1.5, and it's all equal to 84 times 2, and that's 168. So we can continue simplifying. So we have n times minus 12, that's minus 12n, and n times 1.5n, that's 1.5n squared, and n times minus 1.5, that's minus 1.5n is equal to 168. So that means we have 1.5n squared, and minus 12n minus 1.5n, that's minus 13.5n. And taking 16 to this side becomes minus 168 is equal to 0. So I now have a quadratic equation which can be solved by the quadratic formula or otherwise. If I am going to use the quadratic formula, then a will be 1.5, b will be minus 13.5, and c will be minus 168. But I want to use my calculator for quick working. You go to mod, then equation, that's 5, so 5. Then for quadratic, I go to option 3, so that's 3 here. So I can now store my values. So I've got 1.5 for a, then minus 13.5 for b, then minus 168 for c. Which means that I can now say the first value after solving this equation, this quadratic equation, is 16. So n should come out as 16, or the second value comes out as minus 7. So n is equal to minus 7. So we have two values of n here. But since n is number of terms, it has to be positive. So n is equal to 16. So the number of terms as required by the question is 16. So that's the answer right here to this question. Let's go to number 5. The function f is defined for x is an element of all real numbers by f of x is equal to a minus 2x, where a is a constant. So on a, express f of x and f inverse of x in terms of a and x. So let's start with f of x. This means that is the function of, and we are inputting f of x into the function of f, so that will be a minus 2x here. So whatever goes into the function of f replaces the x here. So that will be a minus 2 of, the input is a minus 2x. So that will be a minus 2a plus 4x, which can be simplified to 4x minus a, since a minus 2a is minus a. So that's the expression for f of x. Then for f inverse of x, we can say y is equal to a minus 2x, and we interchange the variables so that it becomes x is equal to a minus 2y. Then we make y the subject, so y will be equal to a minus x over 2, which therefore means that the f inverse is actually a minus x over 2. So that's the expression for f inverse of x. And that's how we answer part A. Now for part B, given that f of x is equal to f inverse of x, find x in terms of A. So now we are equating f of x and f inverse of x. So f of x is 4x minus a. So here I'll be having 4x minus a, and it's equal to f inverse of x, which we got to be a minus x over 2. So let's simplify this. Multiplying both sides by 2 and this side by 2, we'll be getting 2 times 4x, that's 8x, and 2 times minus a, that's minus 2a. It's equal to, this 2's will cancel, so it's a minus x. Then adding x to both sides, we'll be having 8x plus x, and adding 2a to both sides, we'll be having a plus 2a. So that's 9x is equal to 3a, and dividing by 9 both sides, we get x is equal to 3a over 9, which is the same as a over 3, since 3 gets into 9 3 times. So the answer comes out as x is equal to a over 3. And that's how we work out part B. Question number 6. The equation of a curve is y is equal to 2x squared plus kx plus k minus 1, where k is a constant. So on A, given that the line y is equal to 2x plus 3 is a tangent to the curve, find the value of k. So we have right here the equation of a curve and the equation of the tangent. Now we know that at a certain point, the tangent and the curve will meet. And this means that we are going to solve the two equations simultaneously. So since they are all in terms of y, in terms of x, I can say 2x squared plus kx plus k minus 1 is equal to 2x plus 3. And I'll bring everything to one side, so I'll be having 2x squared here, and that's plus kx. And I'll subtract 2x from both sides, so that will be minus 2x. Then I have the k minus 1, and subtract the 3 from both sides, so that will be minus 3, and it's all equal to 0. So that's 2x squared plus kx minus 2x. I can factor out x here, so I'll be having k minus 2 in the bracket, and that's plus k minus 1 minus 3, that's k minus 4 equal to 0. So we now have the combined equation for the curve and the tangent. Now we know that if this line is a tangent to the curve, then it touches the curve only once, and b squared minus 4ac should be equal to 0. In this case, a is the coefficient of x squared, so that's 2. B is the coefficient of x, that's k minus 2, and c is k minus 4. So it means that we can use the discriminant. So b squared, that's k minus 2 squared minus 4 2 of k minus 4 should be equal to 0. Expanding k minus 2, squared, that's k squared, minus 4k plus 4. And 4 times 2 here is 8. So minus 8 times k, that's minus 8k. And minus 8 times minus 4, that's plus 32, equal to 0. This is k squared. And minus 4k minus 8k is minus 12k. And 4 plus 32 is 36. And it's all equal to 0. Factorizing, I'll be having k here and k here. And the factors of 36, whose sum is minus 12, are actually minus 6 and minus 6, which therefore means that k is equal to 6 twice. Therefore, the value of k required by the question is 6. That's the answer here to part A. Let's go on to the next part of the question. It says, it is now given that k is equal to 2. So on B, express the equation of the curve in the form y is equal to 2 of x plus a squared plus b, where a and b are constants, and hence state the coordinates of the vertex of the curve. So right here, I'll take the equation of the curve, which we have in the question right here. So the equation of the curve is this. That's y is equal to 2x squared plus kx plus k minus 1. And since k is equal to 2, that will be y is equal to 2x squared plus 2x plus 2 minus 1, which will just be 1. So this is the equation of the curve if k is equal to 2. To express it in this form, we have to complete the square. So to complete the square, I'll go y is equal to, then I'll factor out the 2. So that will be 2 of x squared plus x. I'll have the 1 remain here. So this will be 2 of, then I complete the square. So I open up my bracket, then that's x plus half of the coefficient of x. The coefficient of x is 1, so half of that is just a half. Then that's squared. Then I subtract that half squared. And that's plus 1. So this will be 2 of x plus a half squared minus a quarter plus 1, which can be simplified to 2 multiplying this is 2 of x plus a half squared, and 2 times minus a quarter, that's minus a half plus 1. So finally we'll be having 2 of x plus half all squared, and minus a half plus 1, that's a half. So this now becomes the equation of the curve, and it's now in this form where a is a half and b is a half. So that's the answer right here. Question number 7. In the diagram, OAB is a sector of a circle with center O and radius 2r, and angle AOB is a 6th pi radians. The point C is the midpoint of OA. So on part A, show that the exact length of BC is r root 5 minus 2 root 3. So here we want to look for the length of BC. And BC is this line here. Now, to find BC, we are going to use the cosine rule. Remember, the cosine rule applies when you have a triangle with 2 sides and an angle in between, which is called theta. So if you want to find x, which is opposite to theta, according to the cosine rule, you say x squared is equal to a squared plus b squared minus 2ab cos of the angle in between, cos theta. So this is like the cosine rule. So we are going to apply that, and we will say BC squared is equal to the side OC squared plus the side OB squared minus 2 times OC times OB cos angle AOB. So that's the cosine rule here. So that will be OC squared is R squared, and that's plus OB squared, that's 2R squared, minus 2 times R times 2R times the cosine of a 6th pi. So this will give us R squared plus 2R squared. 2R squared is 4R squared, so plus R squared, that's 5R squared, minus 2 times R times 2R gives us 4R squared, and that's times the cosine, cos of a 6th pi. Now a 6th pi is 30 degrees, so cos 30, we know that to be root 3 over 2. You can even use a calculator to type this in. So now I'll divide 2 into 4, that's 2 here. So that means that I'll be left with 5R squared minus 2 times root 3, so that's 2 root 3 of R squared, like this. So that means BC squared is equal to, factoring out R squared, I'll be having R squared here, then 5 minus 2 root 3. And then I can square root both sides. So if I square root both sides, I'll be left with BC here is equal to the square root of R squared is R, and the square root of this whole thing will just be and that's the answer right here in the form that they want us to give it as. Let's go on to part B. So part B goes, find the exact perimeter of the shaded region. So if we go back to the shape, the perimeter of the shaded region should mean that we want to know what AC is, what BC is, which we've already obtained an expression for, and also the arc AB. So I'll take the shape here and put it here. So for the perimeter, we're saying would want P is equal to BC plus AC plus the arc AB. That's what will give us the perimeter. So for BC, we'd obtained an expression for BC in part 1, and it came out as R root 5 minus 2 root 3. So that's plus AC. AC is R. And that's plus the arc AB. The length of the arc can be obtained by the formula R theta. So that will be R, that's the radius of the big sector. So that's 2R times theta, which is a 6th pi. So this is what will give us the perimeter of the shaded region. So this will be R times the square root of 5 minus 2 root 3 plus R plus here we get pi R over 3. And we can't simplify this any further, so this gives us the exact perimeter of the shaded region. Let's go on to part C. On part C, it goes, find the exact area of the shaded region. So for the shaded region here, to find the area, we are going to say area of the sector minus area of the triangle OCB. So we're saying area of the shaded region is equal to area of sector minus area of triangle. Now for the area of the sector, the formula is half R squared theta. So we're going to say that's half times R squared. The radius of the big sector is 2R, so that's 2R squared times theta, which is a 6th pi. That's minus area of the triangle. The triangle here has got 2 adjacent sides and an angle in between. And we know that area of a triangle is half side times side sine of the angle in between. So that would be half times side, which is r, times the other side, which is 2r, and sine of a sixth pi. So let's remove this. So we can now simplify. So this will be half times 4r squared times pi over 6 minus half times r times 2r times sine of pi over 6, that's sine 30, which is a half. So this means that I can say 2 into 4, that's 2 here, and 2 gets into 6 3 times. So here I'm left with pi r squared over 3, that's minus, and here I can say 2 into 2, that's 1. So that would be r times this r remaining all over 2, so that's r squared over 2. And if I factor out r squared, that would be pi over 3 minus a half. So this is what I get here for the exact area of the shaded region. Question number 8. The diagram shows part of the curve y is equal to 6 over x. The points 1, 6 and 3, 2 lie on the curve. The shaded region is bounded by the curve, and the lines y is equal to 2 and x is equal to 1. So on A, find the volume generated when the shaded region is rotated through 360 degrees about the y-axis. So with this one, we are going to rotate the shaded region about the y-axis. And to get the volume, we will first need to rotate the curve about the y-axis. So here the limits are going to be 2 and 6, taking it from the y-coordinates. So the y-coordinate here is 2, so it means we've got 2 here, and 6, so it means we've got 6 here. So I'm going to start by rotating the curve about the y-axis, and once I've done that, I'm going to rotate this region here again about the y-axis and subtract the 2 so that I get the volume of the shaded region. Now, to find the volume of revolution when a shape is rotated about the y-axis, we say it's pi times the integral from the lower y limit to the upper y limit of x squared dy. So for this shaded region, we're saying that to find v, we say volume generated by the curve about the y-axis minus volume generated by the line here, which in this case is the line x is equal to 1, since the x coordinate is 1 here. So this is how we get the volume required. So let's start with the volume of the curve. For the volume of the curve, we'll be saying it's pi times the integral from the lower limit, which is 2, and the upper limit, which is 6, of x squared. Now we have the equation as y is equal to 6 over x. If we make x the subject, then it's x is equal to 6 over y. So when we talk of x squared, that's 6 over y squared, and that's dy, and that's minus the volume generated by the line if rotated about the y-axis. Now if you look at this line here and we rotate it about the y-axis, then the 3D shape formed is a cylinder of radius 1 where r is equal to 1. Okay, so volume of a cylinder is calculated as pi r squared h. So we can use that for the volume generated by the line about the y-axis. So we can say it's pi times r squared, the radius is 1, so 1 squared, times height. Now the height of the cylinder is from the lower limit, that's 2, all the way up to 6. So the difference between 6 and 2 gives us 4. So the height of the cylinder h is 4. So we'll be having times 4 here. So we can simplify. Now we've got pi times, now integrating 6 over y squared, we know that 6 over y squared is 36 over y squared, which is 36y to the minus 2. So if we integrate this, then we'll be getting 36 y to the minus 2 plus 1, so minus 1 all over minus 1. Okay, and that's from 2 to 6 minus here pi times 1 squared times 4 gives us 4 pi. So to express it in a better way, we can have pi of, this is minus 36 over y, and that's from 2 to 6 minus 4 pi. So I'm going to remove this. So substituting 6, we'll be having pi of minus 36 over 6 minus, substituting 2 into this, we get minus 36 over 2, and that's minus 4 pi. And we can simplify this further, so that's pi. Then this is minus 36 over 6 plus 36 over 2. So minus 36 over 6, that's minus 6, plus 2 into 36 is 18. So minus and minus 18 gives us plus 18, and that's minus 4 pi. So eventually, we'll be getting minus 6 plus 18 is 12. So that's 12 pi minus 4 pi. And the answer comes out as 8 pi. So we have the answer here coming out as to be 8 pi. Let's scroll down to part B. It says the tangent to the curve at a point x is parallel to the line y plus 2x equal to 0. Show that x lies on the line y is equal to 2x. So right here, according to the question, there is a point on the curve which is a point x. And they're saying here, the tangent to the curve at a point x is parallel to the line y plus 2x equal to 0. Now the key word here is the word parallel. If we have the line y plus 2x is equal to 0, it can be expressed with y subject as y is equal to minus 2x, and we can therefore deduce that the gradient of the line, which is the gradient of the tangent, should be minus 2. That's the coefficient of x. So the gradient of the tangent to the curve should be minus 2. We can also make use of the equation of the curve, which is y is equal to 6 over x. So y is equal to 6 over x. We can use this equation to also find the gradient function. So we can say dy by dx is equal to, you see 6 over x is 6x to the minus 1. So when we differentiate it, we bring down the minus 1. Then we have the 6. Then x power minus 1 minus 1. So it becomes minus 2. So dy by dx here comes out as minus 6 over x squared. So this is the gradient function. Now the curve at the point x has the same gradient as the gradient of the tangent, which means that we can equate the gradient function minus 6 over x squared to the gradient of the tangent, which is minus 2. So I'll multiply both sides by x squared to get minus 6 is equal to minus 2x squared. And dividing both sides by minus 2, I get x squared is equal to 3, which gives me the value of x after square rooting both sides to be plus or minus the square root of 3. But we know that if we go to the graph, you can see that the graph is on the positive side of the axis, so x should take a positive value. So from plus or minus root 3, we'll therefore take x to be positive root 3. Now, if x is equal to root 3, then what is y? So we can use the equation of the curve, which is y is equal to 6 over x, to find the value of y. So that will be y is equal to 6 over x, which is root 3. And if we rationalize the denominator by multiplying by root 3 over root 3, then it means we'll be having 6 root 3 over root 3 times root 3 gives us 3. And dividing 3 into 6, we get 2. So we get 2 root 3. So we have x being equal to root 3. And we also have y coming out to be 2 root 3. And I think you can notice the relationship that y is actually 2 times x, because x is root 3, y is 2 times root 3. So the relationship between x and y is coming out to be y is equal to twice x, or y is equal to 2x. And that's what they want us to prove for this question. Show that x lies on the line y is equal to 2x. So we have thus proved it, hence shown. And that's the solution to this question. Let's go to question number 9. Functions f and g are such that f of x is equal to 2 minus 3 sine x for 0 to pi, and g of x is equal to minus 2 of f of x for 0 to pi. So on A it says state the ranges of f and g. Now for the function f of x, you look at the function sine, and we know that for the graph y is equal to sine x, the range for y is plus and minus 1. So when we have now 2 minus 3 sine x, it means the range will now be 2 minus 3 of the range of sine 2x, which is plus and minus 1. So that's plus and minus 1. So we're going to have 2 minus 3 here, which is minus 1, and 2 plus 3 here, which is going to be 5. And therefore, the range of f comes out between minus 1 and 5. So that's the range of f. And this therefore means for g of x, since g of x is minus 2 of f of x, it means we're going to multiply the limits of the range of f times minus 2. So 5 becomes the lower limit when multiplied by minus 2. So that will be minus 10. And multiplying minus 2 times minus 1, we get 2. So the range will be from minus 10 to 2. So that's the answer here for the range of g of x. Let's go to the next part of the question. So the diagram shows the graph of y is equal to f of x. So on part B, it says, on this diagram, sketch on this diagram, the graph of y is equal to g of x. Now, we know that the function g of x, according to what we've been given, is minus 2 of f of x. So it's minus 2 of f of x. And we have the graph of f of x right here. Now, this represents two transformations. The first one, represented by the negative sign, is a reflection in the x-axis. And the second transformation, represented by the 2, is a stretch parallel to y by factor 2. So we are going to perform these two transformations. Okay, so first of all, the graph is going to be reflected and it is going to be stretched by factor 2. So for me, the graph will come out like here, goes up, then down, the x coordinates are not affected, then down, then up, maybe like this. So this is how the graph of g of x should come out. So it's showing us two things. Number one, the fact that the graph of y is equal to f of x has been reflected. That's why it's now flipped upside down. But besides being flipped upside down, it's also been stretched by factor 2. So that's why it's now looking a bit more stretched than it originally was. So this is more like the sketch that is required here. Let's go on to part B. The function h is such that h of x is equal to g of x plus pi for minus pi to 0. Describe fully a sequence of transformations that maps the curve y is equal to f of x onto h of x. Okay, so here we're starting with the original graph as f of x. F of x gave us the graph g of x, and now g of x is being transformed onto another graph, which is h of x. Now, from f of x to g of x, what was the transformations? We learned from the question that g of x is minus 2 of f of x. So we had g of x being equal to minus 2 of f of x. So we said this represents a reflection in the x-axis. That's represented by the negative sign, and also followed by a stretch parallel to the y-axis by factor of 2. And then here, from g of x to h of x, we hear that h of x is g of x plus pi. Now the plus pi here is a constant inside the bracket. So we know that f of x plus a represents a translation parallel to the x-axis by a units in the negative x direction. So we can say that is a translation by pi units in the negative x direction. So these here are the 3 transformations for 3 marks, and that's the answer. Let's move on to question number 10. On number 10, the equation of a curve is y is equal to 54x minus bracket 2x minus 7 all to the power of 3. So on A, find dy by dx and d squared y by dx squared. So let's start by finding dy by dx. So we're saying differentiating 54x, we get 54 minus differentiating 2x minus 7 to the power of 3, we'll bring down the 3, then the derivative of 2x minus 7, which is 2, then we write down 2x minus 7 as it is, and then to the power of 3 minus 1, which is 2. So this can be simplified to 54 minus 6 of 2x minus 7 squared. And for the second derivative, we can differentiate the first derivative. So the derivative of 54 is 0. Then here we've got minus 6, bring down the 2. Then derivative of 2x minus 7, that's 2. Then 2x minus 7, then 2 minus 1, which is 1. So this can be simplified to minus 6 times 2 times 2, that's minus 24 of 2x minus 7. So this is the second derivative. Let's go to part B. Find the coordinates of each of the stationary points on the curve. So we know that at the stationary point, dy by dx should be equal to 0. So the gradient function, we got it as 54 minus 6 of 2x minus 7 squared, so it has to be equal to 0. So this will be 54 is equal to, putting this to the right, we'll be having 6 bracket 2x minus 7 squared. Dividing both sides by 6, we'll be having 2x minus 7 squared is equal to 6 into 54, that's 9. And if I square root both sides, then I'll be having 2x minus 7 is equal to plus or minus 3. So x can come out as 7 plus or minus 3 all over 2 if I solve for x. And therefore, the two values of x are going to be 7 minus 3 divided by 2. So the 7 minus 3, that's 4. And 4 over 2 is 2. And also 7 plus 3, that's 10. And 10 over 2 is 5. So we have two values here. So what are the y values? So for the y values, I'll use the original equation, which is right here. So taking the original equation and placing it here and substituting 2 first. So when x is equal to 2, it means I'll be having 54 times 2. That will be 54 times 2 minus 2 times 2, that's 4, minus 7 cubed. So that's 54 times 2 is 108, minus 4 minus 7, that's 3 cubed, is minus 27, so it's like plus 27, and 108 plus 27 gives us 135. So we'll be having 135 here. So 135 is one of the answers. Then again, if x is equal to 5, then substituting it into this equation, we'll be having 54 of 5 minus 2 times 5, that will be 10 minus 7 cubed. So 54 times 5 is 270, and that's minus 3 cubed, that's 27 there. So 270 minus 27, we get 243. So y is 243. So we also have 243 here. So we have two coordinates, that's 2, 135, and 5 and 243. So that's the solution to part B. Then on part C, determine the nature of each of the stationary points. Now for the nature of the stationary points, we are going to need the second derivative. So that's d squared y by dx squared. And we'd already gotten that in part A, and it came out as this. So I'll paste it here. So this is what we got for the second derivative. So we're going to use x is equal to 2 and x is equal to 5 to determine the nature of each of the stationary points. So we're saying for the point 2, 135, the second derivative is, we substitute 2 into this. So that's minus 24 of 2 times 2, that's 4, minus 7. So that's minus 24 times 4 minus 7, that's minus 3. So it's minus 24 times minus 3. And that gives us 72, which is positive or greater than 0. And therefore, this is a minimum point. And again, for the point 5, 2, 4, 3, the second derivative will be minus 24 of 2 times 5, that's 10, so that's 10 minus 7, so that's minus 24 times 3, and it gives us minus 72, which is less than 0, and therefore a maximum point. So that's the answer there to part C. Question number 11. The equation of a circle with center C is x squared plus y squared minus 8x plus 4y minus 5 equal to 0. So on A, find the radius of the circle and the coordinates of C. So here we've got the equation of the circle x squared plus y squared minus 8x plus 4y minus 5 equal to 0. I'm going to regroup the terms, so that's x squared, grouping it with minus 8x. Then we have y squared, grouping it with 4y. And I'll take the 5 to the right hand side. And I'm going to complete the square, starting with x squared minus 8x. So that'll be x minus half of minus 8, that's 4. That's squared. And I subtract the 4 squared. And that's plus. For y squared and 4y, that's y plus 2 squared, and that's minus 2 squared, and that's equal to 5. So I have x minus 4 squared, and I have y plus 2 squared, and that's equal to 5. I'm going to add minus 4 squared to both sides, so I'll be having plus 4 squared, which happens to be 16. And I'm adding minus 2 squared to both sides, so that's minus 4, so that'll be plus 4. So eventually I'll have the equation of the circle in this format. So 5 plus 16 plus 4 gives us 25. So this is now the equation of the circle. So I can now deduce the center, coordinates of the center C are going to be minus of minus 4, so that's 4, and minus 2, that's minus 2. So that's the center. And as for the radius of the circle, it will simply be the square root of 25. So that's root 25, and it comes out as a 5. So these are our answers. Coordinates of the center and the radius is 5. And that's it for part A. Let's move to part B of the question. The point P of coordinates 1, 2 lies on the circle. Show that the equation of the tangent to the circle at P is 4y is equal to 3x plus 5. So the situation here is like we've got a circle and we have a point here which I want to call P. So the coordinates of P we've already been given, and the question is saying there's a tangent at P to the circle. So the question is, show that the equation of the tangent to the circle at P is 4y is equal to 3x plus 5. Now for the equation of the tangent, since it's an equation of a line, I would need to know, number 1, the gradient of the line. And we know that the gradient of a tangent is perpendicular to the radius of the circle. So they meet at right angles. So first of all, I'll look for the gradient of the radius. So this is the center C, and we've got P here. So let's say gradient of PC. All right, so we're going to use the coordinates. The coordinates of the center, we got them to be 4 and minus 2 here. So we're saying C is 4 and minus 2. So the gradient will be minus 2 minus 2. That's the difference in the y coordinates, divided by 4 minus 1. And this is going to give us minus 2 minus 2, that's minus 4. And 4 minus 1 is 3. So the gradient of PC is minus 4 over 3. So therefore, we can deduce the gradient of the tangent which has to be the negative reciprocal of minus 4 over 3. So it comes out as 3/4. Remember, the products of the gradients of perpendicular lines should multiply to give us minus 1. So now that we have the gradient of the tangent, we can now work out the equation of the tangent using the formula y minus y1 is equal to m of x minus x1. So we can say here y minus, using the coordinates of p, the y coordinate is 2, so it's y minus 2 is equal to 3/4 of x minus the x coordinate, which is 1. So that's y minus 2 is equal to 3/4 of x minus 3/4. And if I multiply all the terms by 4, so every term by 4, I'm going to get 4y minus 8 is equal to, the 4's will cancel here, so that's 3x, and the 4's will cancel here, we've got minus 3. And then to rearrange, I'll have 4y remaining on the left side, and I'll add minus 8 to both sides. So I have 3x here, and minus 3 plus 8 gives us 5. And we thus have the equation of the tangent as required by the question right here. So that's how we do it for part B. Let's scroll down to part C. The point Q also lies on the circle, and PQ is parallel to the x-axis. So write down the coordinates of Q. Okay, so let's make use of the sketch that we have already obtained right here. So I'm going to take this sketch, and we want to make use of it here. Okay, so according to the information given, we have another point Q on the circle. So I'm going to say Q is maybe around here. So that's Q. And they say Q also lies on the circle, and PQ is parallel to the x-axis. So I'll draw the line PQ right here. So they say this line PQ is parallel to the x-axis. So we have the x-axis somewhere down here, maybe, or wherever it is. So that's the x-axis. So we will have the y-axis maybe also somewhere around here. So this is just a sketch to help us understand the question better. Okay, so for the coordinates of Q, we can do this. We can start with the x coordinate. So the x coordinate of Q is around about here. And we know the x coordinate of C, the center. Remember the coordinates of the center, C, are 4 and minus 2. So the coordinate, x coordinate of C here is 4. And the x coordinate of P, we've been given that the coordinates of P is 1 and 2. So 1, 2 for P. So P is 1, 2. So the x coordinate is 1. So I think just using geometry, the length from 1 to 4, which is 3 units, should also be the length from the x coordinate of C to the x coordinate of Q, which should also be 3. So this means that the x coordinate of Q should come out as a 7 here. So the x coordinate is 7. And then you can also see that since PQ is parallel to the x-axis, then the y coordinate of Q, which we can read on the y-axis, should also be the same as the y coordinate of P, since they're on the same level. So the y coordinate of P is 2. It therefore also means that the y coordinate of Q should also be 2. So we now have the coordinates of Q. That's 7, 2. And that's how we deduce the coordinates of Q. Let's go on to part D. The tangents to the circle at P and Q meet at T. Find the coordinates of T. So again, I'm going to use the sketch. Remember, we'd say the point Q can be here. So the tangent to the point Q, which is here, they say it meets the tangent at P at a point T here. So the question is, find the coordinates of T. Now, in order for us to find the coordinates of T, we would need to know the equations of both tangents. Now, we'd already obtained the equation of the tangent at P, and we got it all the way in part B. That's 4y is equal to 3x plus 5. So, equation of tangent at P is 4y is equal to 3x plus 5. So we already have this. So now we need to find the equation of the tangent at Q. For the equation of the tangent at Q, we know the coordinate of Q. We got them to be 7, 2. And we also need to know what the gradient of this line is. Now, we can also use geometry to see that by symmetry, that the tangent at P is a reflection of the tangent at Q, which means if we had found the gradient of the tangent at P to be 3/4, then the gradient of the tangent at Q should be -3/4, and that's by symmetry. So it means we can now find the equation of the tangent at P. Y minus 2 is equal to the gradient, which is -3/4 of x minus 7. So we can simplify this. So this will give us y minus 2 is equal to -3/4 of x, and that's plus 21/4 if we multiply this 2. I can multiply all the terms by 4. So 4 times all the terms. And this will give us 4y. And 4 times 2, that's -8. And the 4's will cancel here to get -3x. And the 4's will cancel here to get plus 21. And this is 4y is equal to -3x plus 21, and adding -8 to both sides, that's plus 8. So that's 4y is equal to -3x plus 29. So this is now the equation of the tangent at Q. Now the two tangents are meeting at T, which therefore means I can solve the two equations simultaneously. Now both equations are in terms of 4y. So 4y for the first equation is equal to 3x plus 5. And 4y on the second equation is equal to -3x plus 29. So I can solve for x here. Adding 3x to both sides, I'll be having 3x plus 3x. And subtracting 5 from both sides here, I'll be having 29 minus 5. So 6x is equal to 24. And dividing both sides by 6, I get x is equal to 4. And if x is equal to 4, what is y? Let's take equation 2. So from equation 2, that will be 4y is equal to -3 of x, of which x is 4. So of 4 plus 29. So that's -12 plus 29 is equal to 4y. So 4y is equal to -12 plus 29 is 17. And dividing both sides by 4, we get y is equal to 17/4. So the coordinates of T should come out as x coordinate is 4 and y coordinate as 17/4. And that's the answer right here to this question. And that concludes the paper. Thank you for watching, and subscribe to my channel. Thank you.